And thank you for the opportunity to do this. And thank you, Jake, as well, for putting up with me throughout the process. So yes, like Rob said, I'm a data nerd as well, and realize that a lot of people don't know what data science is, and there's a lot of buzz going around right now about it. So I actually uh, spent my entire life, or a good part of my life, thinking I was going to be a doctor because I loved math and science. And so um, I started working for a hospital and quickly found that I was gravitating towards the data driven projects. And so I kind of wrote my own job description during a time that there weren't that many data related jobs at all, especially in healthcare. And so after a year or so of that, using spreadsheets, kind of data munging haphazardly, I realized that I needed a lot more tools, kind of in my toolkit, to really leverage all of the data that the hospital had, um, that I was working for at the time. And so I started looking for, I first took a course on Coursera on graph theory and realized I was just pretty smitten with um, data and the whole thing. And so um, around that same time, I joined a meetup group that was really a baby at the time called Data Science ATL, which I'm now the main organizer of, and has sort of led to Data Science Connected in general, which we're now the largest data science community in the southeastern United States. Um, but anyways, I joined the group in 2012 during a time when no one really knew what data science was. And so I would tell my friends, like, sorry, I can't hang out. I'm going to a data scientist event. And they'd say, what is a data scientist event? And so, and so when those, and it happened without fail almost every time. And so when those questions stopped coming in, I realized that data science was finally a household name. So today we're just going to talk through just very high level, and apologies to you, Rob, if it's a little too high level. And apologies to the rest of you who are going to probably have eyes glazed over for a bit. But we're all touching data now. It touches every industry, it touches every role. And very timely now. It's something we're talking about all the time with the current COVID-19 crisis. And so it's not unlikely to turn on your news channel and hear them talking about data-driven decisions or flattening the curve. And so even if you are not a data scientist or are not interested in building models or really utilizing it like first person, we're all exposed to data science now. And so the purpose of today is just to kind of walk you guys through the high level, um, sort of the high level of data science, the tools, the lingo, and we'll get kind of under the hood and walk through um, sort of the framework of data science with models and the scoring a model and testing it, and then sort of where I'm seeing it go. Just with almost 10 years in the industry, it's been really neat to see the industry evolve and transform. And so sort of what the landscape looks like right now and where I think it's about to go. And then finally, just wrap it up quickly with how it can become immediately useful to you and how you can leverage it in your own careers. So we'll start out with just sort of the terminology. So data science, the way I describe it is we're collecting all this information. Our cell phones, our cars, our everything is collecting information now. So essentially, if it has an on button at this point, it's collecting information because it's most likely connected to the internet. But so data science is about sort of a mix of statistics and technology and programming, and it all kind of comes together to leverage all of this data and turn it into knowledge. So you've probably already heard of a lot of these tools, but there's three major tools or sort of platforms that are used within the data science industry. And so it kind of depends on when you enter the data science industry, which preferences is yours. And so Loli, she used to be the CIO at Spanx, calls it the battle of the tools, but everyone kind of has their favorite. And so you'll notice that the kids these days are kind of all leaning towards Python. I'm more of a R girl. And then my professors in my master's program were primarily SAS dependent. So it sort of depends on when you entered the industry and kind of latched onto your tool. SAS is more stats driven. It's You're going to find it in larger enterprises. Um, it's not free, not open source. Then you're going to see R and Python. R is open source. It's also pretty stats driven and more of an exploratory data viz tool versus Python, which is also open source and free. But Python is where um, you can really productize it and it scales really nicely. So that's what's sort of the engine behind a lot of products. Um, then we've got models. So this is not your typical modeling. This is your nerding modeling. So that you'll hear AI, machine learning, deep learning, natural language processing, all these buzzwords, and they're sort of kind of whether they're Russian dolls within one another. And so artificial intelligence is sort of what's the umbrella over sort of the modeling components. And that's basically just a loose term for when data science and models interact with humans in an intelligent manner. And so within artificial intelligence is a more narrow umbrella that is machine learning. And that's where the machine is making, you teach the machine to learn from the data. And so it can eventually have its own intelligence and make decisions itself based on the data. And so within that is deep learning, and that's sort of the next level, and it's really getting traction right now in the industry. And deep learning is actually modeled after the way our brains work. Um, and so it's sort of studying a lot of different layers within machine learning. And then natural language processing is sort of, I would almost say it's sort of kind of on the cusp of all three of these, and it's making sense out of human language. And so if you were scraping Twitter for like during the campaigns to see, for instance, you could look at the semantics and see if people are speaking positively or negatively about Biden or Trump. So that's an example of NLP. So within models, there's a lot of different algorithms like linear modeling or Bayesian models, or there's a lot of different ones, but there's two major subsets, and it's either supervised learning or unsupervised learning. And so supervised learning is when you already have the data labeled. So it's, this is a duck, this is not a duck. And then the machine learns it, and then it can predict it afterwards. But unsupervised learning is kind of exciting, and that's where where it's going to find the patterns that we wouldn't know are there. And so instead of saying this is a duck, this is not a duck, it's going to say these ducks or these birds sort of look the same. And this rabbit doesn't really look like anything else. And then this porcupine over here doesn't really look like anything else either. And that's where we learn from the data. And that can be a really powerful tool. And then sort of the next step from that is after you build your model, you train the model. And so typically you split your data randomly into 70-30 or 80-20, with 70% of that being your training data and 30% being your testing data, which is what, so the training data is what you train the model on, and the testing data is what you already know is correct. And you can use that to look at the accuracy of your data model and see if it correctly classifies it or correctly identifies it. So following that, like I said, with the test data, you'll, this is sort of the back end of what that scoring algorithm looks like, but it's basically going to show you how accurate it is based on how many, how many your model got right and how many it got wrong. And so it's basically when it was, for instance, like in this case, like when it didn't classify it as something, but it should have been, that'd be a false positive. And then, anyways, vice versa. And so the accuracy score is dependent on how many true positives and how many true negatives over all of the data. That's called a confusion matrix. And then data viz is another buzz term that's going around right now, and that's something that previously I think a lot of us neglected, but it's really an important part. Is because it's where the data really comes alive, and that's when you tell your story. And that's basically just it could be in the form of bar charts, graphs, scatter plots, box plots. It goes on and on, but that's when you sort of visually tell the story of your data, and that's a really powerful component. And you can find that with Tableau, or there's a lot of Click. There's a lot of platforms that you might be familiar with that you can use that for. And so just wrapping it up in terms of what we just talked about, you'll get context, you'll ask the questions about your data science problem, and then you'll find the data and clean the data, which is, I think we probably spend 70% of the time sort of in that area, in the data cleaning and munging. And then you'll, if it's supervised learning, you'll define the features, which would be, in the case of the birds, it would be these are birds, or and then the next step would be building the model, and then scoring the model, and then the final step is telling the story with the data visualization. Okay, so now where it's going. So you might have heard about democratizing data. So that's basically just a fancy term for data either being open within an organization, regardless of role or function. And so previously, you're probably aware that IT was sort of the gatekeeper of data, but there's a strong shift right now in the industry where organizations are recognizing that giving access to their entire company, access to that data, can be really valuable and be a really strategic option in terms of leveraging that. And then on a sort of in a broader sense, open data models in general are sort of a trend we're seeing right now in the industry as well, which would be in the case of like COVID-19, John Hopkins and major organizations are coming together and making their data public. And it's really a beautiful thing. But so that's sort of the open data model. And then you might be familiar with the Internet of Things. And so that's IoT. And so basically, like I said before, if it has a start button or an on-off button, it's likely connected to the internet these days, which means eventually all of these different, like our Fitbits are connected to our to the internet, or our Alexa is now in our car. And so eventually it's going to have a lot of implications in terms of monetizing data. For instance, Verizon and AT&T are going to have data that they're going to have GPS related data on how many people cross this stoplight at a certain time of day. And you could eventually sell that to a marketing company that's going to sell advertising space in that intersection. And so that's an example of sort of monetizing and leveraging IoT, and the implications are just going to get more and more. So data ethics and privacy is another big conversation right now in data science. And so basically I kind of see it as a sort of a race between policy and data. So an example of that is like genomics is actually what got me into data science ultimately, is and DNA and our sort of our human blueprint in general is so incredible, but it's as we there's a lot of laws coming up around protecting DNA and our human genome and that sort of thing. And so it's hard for us to leverage data that we don't have access to anymore. And so to sort of build on that, there's also it's also really important for particularly with data scientists to understand the implications of the models that they're building out and what that could mean later on. So for instance, if you're building a model to track, that uses credit rates to predict what kind of driver you're going to be, that could eventually mean that you're going to pay more if your credit's bad, or if you're of a certain demographic, you are going to pay more for your car insurance. And that's pretty controversial. Um, and so it's sort of coming down to what is ethical and what isn't. And what I like to say is, I think where things get really dicey is no one really thinks they're building a model that's not ethical. And so it's a matter of what is ethical. Um, and so it's okay. So my argument is that in terms of determining what's ethical, is that it. Oh, sorry, I'm sorry, Rob. I'm just seeing your questions. I'll explain those in just a second. But so I suggest using data to determine what's ethical, and sort of scoring that, instead of saying, "Oh, this something went wrong. We've got to do away with it." Versus, so Bill Franks is a thought leader in the industry, and he um, has studied a lot around this, the data ethics and privacy space. And he uses a story about a friend of his that got into a car accident, and she actually wasn't wearing her seatbelt, and they told her that she would have not survived the wreck if had she been wearing her seatbelt. And his argument is, it would be really tempting to say, okay, so now we just don't need to wear seatbelts, no more seatbelts. But from a data perspective, does that really make sense? Um, we know that the majority of people wearing seatbelts are going to have good outcomes if they're in or better outcomes if they're in a car accident. Mm, Democratization of data in terms of sales. Um, so what that could mean is, even like I was just talking about the geolocation data that our cell phone providers are collecting right now. That could mean that's really valuable data from a sales monetization perspective. And so making that type of data open and available could have some really um, exciting implications in terms of sales or marketing or that sort of thing. Did that answer your question, Rob? Okay, good. Um, okay, so this is a space that's really exciting to me. So it's what we're seeing now is, I don't know if you guys have heard of Data Robot, and there's a couple other companies that are similar, but um, there's a shift now in the market of where um, we're actually automating the data science process and just in general. And so computers are now building the models and running it almost in a Monte Carlo like simulation in a way that we could never outperform, and figuring out what the best algorithm is, what the best score is, and doing all of this all at once. Um, and then kind of doing that work for us. And this is going to be kind of controversial, but just taking a few steps back, I think what this means, um, at least initially, is, or the first thing they'd probably go is programmers and coders. And so I think that component of data science is going to become less and less important in a data science role as computers sort of take on um, coding, and then eventually are already taking on building and scoring models and outperforming humans. And so I think that's kind of an exciting shift as well. Um, and so what I'm really passionate about in data science, and where I really see the future going, that a lot of people do not recognize yet, is that because data science is industry agnostic, it transfers, that the same approach or the same model could transfer really nicely across industry. And so an example I read the other day is oil and energy companies are using, or the oil and energy industry is using, they took a model from the healthcare industry on survival rates of patients based on a number of variables like their age, their comorbidities, demographic, all of these different things. And so they're using it now, almost the exact same model in the energy and oil industry to predict the lifetime of equipment. And so that's kind of a using survival analysis across industry is a neat. Yeah, we definitely do need to talk more. um, Anyways, it's a neat, kind of a neat transfer. And that's where I think to speak more about data democratization, what I think could be really exciting is having these open models across industries, where one industry can leverage a model that's been really useful in another industry. Um, and so I think that's a really exciting sort of thing on the horizon that a lot of people are sort of sleeping on right now. Yes, stock market too, and private equity. You'll see a lot of private equity models being used across different industries too. Um, and then, sort of to come back to where we're at, just even in terms of this presentation, being able to, even though you may never build a data model, you may never open R or Python or um, never do any of that. You're using it all the time. And so it's important that we have some sort of data translator and some sort of um, translation where we are speaking the same language. The executives understand what the data person's saying, that the data person understands the business problem. And so um, data translators and people that can speak both languages are going to be increasingly important as time goes on. And so um, you guys will be your own, even if you're not data people, um, you can be your own citizen data scientists now. Yep. Yeah, Rob says all the answers are there. It's just in a language that most humans cannot understand. And that's a good way to put it. And then lastly, AR and VR, which is augmented reality and virtual reality, which are going to be sort of, I think, change the game in terms of data science and how we live our lives. And I couldn't help but think during this, I need to speed up. I couldn't help but think, but that during this sort of virtual life that we're living in right now, if we had augmented reality and virtual reality um, that was more sophisticated and more like usable and ready to use, we could be interacting in a much more advanced virtual way than we are right now. 5 minutes. Okay. And so that's technology dependent, but that's going to be a big shift in the future. And then lastly, just how to leverage it. And so I don't know how many of you made it to Brian Mink's presentation that was a little earlier, but in terms of data collection and becoming data ready, it takes steps. What he suggests and what I like to suggest as well is collecting the data and structuring the data in a way that creates immediate ROI. That's the only way you're going to get have a good business case for implementing data science, especially outside of a data science department. And so creating checklists, leveraging your CRM platforms, all of these things are ways to structure your data and make yourself data ready. And then having that infrastructure in place and then making sure that it fits in with current processes. Otherwise, it's not going to work. And yeah, like I said, take baby steps. And data is everywhere. It's in your HR systems. It's in your CRM. And an example I like to use is a few years ago, I built an app for it was a quality training company that worked with healthcare systems, and they basically just had structured data that was employees' names, their addresses, who they reported to, which immediately looks like really stale data. But we made this really incredible dashboard where hospitals, for example, could find that certain employees had a higher turnover if they lived longer distances away from the hospital. And so by simply using the employee home address, you could find some very interesting information. And then lastly, you don't have to be a data scientist to leverage data. It's everywhere. It's really not as scary as it seems. The computer does a lot of the work for us these days. So get your hands dirty and try it out. Do like I did at the beginning and take a Coursera course. There's a good one called the Data Science Toolkit, where you can kind of delve in and get a feel for data science. And you'd be surprised how quickly you can kind of build out your own data projects. And then finally, we've got a lot of upcoming events. We actually have a COVID-19 analytics panel next week that's free. Following that, a supply chain then one on the sharing economy, and then on one on HR analytics. And like I said previously, you don't have to be in any of these industries to leverage what these folks are doing. A lot of times the value comes from learning from the other industries, and to get cues and ideas of how to apply them to your own industries. And then we have 3 conferences later this fall, probably not in person, hopefully though, but they'll be virtual either way. And you'll all be familiar with the virtual environment now and the virtual conference experience. And that's it for me. Thank you so much to White Rabbit for this opportunity. Thank you, Rob. Thank you, Jake. I'm sorry I didn't leave much
No problem.
questions.
Gotcha. Yeah, no, that's no problem. We're gonna be good here. I need to hop on to the next. So,
Great.
thank you so much. And yeah, we definitely need to talk after this
Yeah, I
about
would love to.
the democratization of data. That's super interesting, and I can get into that so far. So,
Okay, let's start off.